Okay, here we go. So today we're starting Introduction to Functions. Introduction to Functions. I'm going to give you the I can statement that goes in that box. It's 3 sentences, so I had to write skinny. So here's what it is. I understand what a function is. God bless you. What a function is. Period. I understand what a function is. Here's why. I can identify the domain and range and I'm going to put a comma there. I can identify the domain and range, comma, and I can identify a function from tables, graphs, mappings, mappings, and sets of ordered pairs. Eventually, you'll be able to identify a function from an equation, but we're not there yet. So I understand what a function is, period. I can identify the domain and range, and I can identify a function from tables, graphs, mappings, and sets of ordered pairs. Everybody good with that? I see a couple of you are still writing. So we have some vocabulary. So the first vocabulary term that we're going to talk about is a function. So a function is just a clearly defined rule that converts or maps an input, which is an x value, into exactly one, this is important, exactly one output, which is a y value. So it's a clearly defined rule that converts or maps your input, which is your x, right, into exactly one output, which is your y. And that phrase exactly one is important, okay? All right. So the rule, is everyone good with that? Okay. So the rule that defines a function, sorry, I'm scrolling down, can be in several forms. The first one can be in the form of an equation. Can be in the form of an equation. It can be in the form of a table, an XY table or XY chart. It can be in the form of a graph. It can be in the form of a set of, what do you think this is going to be? We just wrote it in our definition. Ordered pairs. Who said that? Good job, Tim. A set of ordered pairs. Remember that ordered pairs look like this, right? X, comma, Y. Do we remember that's what ordered pairs look like? Okay. And a mapping. You guys do know that you have highlighters in your buckets, right? In front of your desks. So I'm highlighting the vocabulary terms. Why? Probably because they're going to be really important. So I suggest you maybe grab a highlighter and highlight those, or put a box around it or something, because they're important. They are important. All of you guys have little buckets attached to the front of your table groupings. I'm going to keep going. That should not require talking. We have 17 minutes. The set of inputs, domain, is the set of inputs known as your X values. The range is the set of outputs. Range, I'm going to highlight that, is the set of outputs known as the Y values. Yeah, good job. We have a tool that we use. It is called the vertical line test. And we use it to determine if a graph represents a function. And we're going to demonstrate that today. We use it to determine if a graph represents a function. And then lastly is a mapping. A mapping is, I'm going to just draw a little sketch of a mapping down here. It looks like these two bubbles, where this is your domain and this is your range. And you see numbers in here and then arrows going across. Have you guys ever seen something like that? Yeah, you have. That's called a mapping. That's what a mapping looks like. And I've got some in our examples, okay? So a mapping is just a mathematical relation in which each term in the domain is mapped to a term in the range. That's all that is. Each term in the domain is mapped to a term in the range. So I want to get through examples 1, 2, and 3. And then I'll get you guys started on finishing up your test. Can I go to the next page? Okay. So we're going to go to example number 1. Example number 1. So here, example number 1 says, function rule given in verbal form. So this is a rule given in verbal form. And you guys struggle with translating a verbal into a actionable equation or identifying operation words. So here is the rule. It says that we're going to divide the input by 2. What is the input value represented by? X. So we're going to divide the input value by 2. That's what that says. And then we're going to do what? We're going to add 3 to that. And that's going to give us our, it says our output. What do we use to represent our outputs? We just wrote it, which is represented by the letter Y. Okay. So that is our rule. Divide the input, so divide X by 2, and then add 3. So I'm going to rewrite this rule down here. So X divided by 2 plus 3 equals Y. That's the rule. That's what we're saying is going to happen. So now we're going to do a little bit of math to show or like calculate what our outputs would be. So your input, remember, is your X value. your output is your y value. So if x is 0, this looks like 0 divided by 2 plus 3. What is 0 divided by 2? 0. What is 0 plus 3? It's 3. My output is 3. Well, what if my input or my x value is 2? Well, that looks like 2 divided by 2 plus 3. But what is 2 divided by 2? 1. And 1 plus 3 is 4. Okay. What if my input or my x value is a 4? Well, that's 4 divided by 2 plus 3. And 4 divided by 2 is 2. Plus 3 is 5. 2 plus 3 is 5. When my input or my x value is 6, I get 6 divided by 2 plus 3. But what is 6 divided by 2? 3. And 3 plus 3 is 6. All we're doing is evaluating this rule by substituting in for x. That's all we're doing. We're taking our input and plugging it in. What about when my input is 8? So when x is 8, that's 8 divided by 2 plus 3. What is 8 divided by 2? 4. Plus 3 is, okay. And the last one, when my input is 10, well, that's 10 divided by 2. And 10 divided by 2 is 5. And when I add 3 to that, I get 8. Whoops, sorry. I can't talk and write at the same time because I messed myself up. So plus 3 equals 8. So we're going to use this input-output and make a graph. We're going to use that input-output values and make a graph. So these are your x values, which remember are your inputs. And these are your y values, which remember are your outputs. So when I started with x equals 0, when I input the number 0, what do I get out? I got out a 3. So when x is 0, that's right here. My output is 1, 2, 3. Plot that point. So that is the ordered pair 0, 3. What about when x is 2? When x is 2, what is my output? 4. That is the ordered pair 2, 4. What about when x is 4? My output is 5. Oops. So that's the ordered pair 4, 5. What about when x is 6? My output is 6. That's the ordered pair 6, 6. What about when x is 8? My output is 7. That's the ordered pair 8, 7. And what about when x is 10? When x is 10, my output is 8. That's the ordered pair 10, 8. How do we feel about that? We just plotted points, right? Everybody knows how to plot ordered pairs on a graph. Yes? Okay. Raise your hand if you need more time. All right, let's go to our next example. There are filled out copies up front. I was going to wait till we were all done with the lesson.
Yeah, I think that might be
Yeah.
that.
Graphs are an excellent way to show a function rule. The graph below shows a relationship that is a function. We have to answer the questions based on the graph. So we're looking at this graph. that has all of these points plotted, and we're going to have to answer some questions. So I'm going to kind of color over these maybe in yellow so they hopefully pop on the screen for you so you can see them a little bit better. Oh yeah, that would be so awesome. Thank you so much. We're going to shut down the lights for a second just because I think that this is important. Perfect. So state the outputs for each of the following inputs. So when we input -1, meaning when we let x equal -1, so this is my x-axis right here. Does everybody see this? So if this is 0, 0, -1 is right here. I have to find out what my output is. So when I input the number -1, what is my output? Where is this along the y-axis? What do you got, Owen? -4. When I input the number 5, so x equals 5 right here, when I input the number 5, my output is going from what number on the y-axis? My output coordinates to what number along the y-axis? 7. Good job. When I input the number 9, 9 along the x-axis is right here. My output coordinates with what number on the y-axis? 3. These can be written as ordered pairs. -1, -4, 5, 7, 9, and 3. Can two different inputs have the same output? Let's see. So if I were to input the number, so can two different inputs, like if I let x equal 4 and I let x equal 7, can they have the same output? Y equals 2, y equals 2. And the answer is yes. Two different inputs can have the same output. The answer is yes. However, question C says, if we add the point, that's an ordered pair, to -4, would this graph be a function? Why? Let's look carefully at the definition. So if we add the point to -4, so here is the point, x is 2, y is -1, 2, 3, 4. This is the point that I'm adding. I'm adding the point to -4. I'm adding the ordered pair to -4. Put that on your paper. Put that on your paper. Plot that point to -4. Is this still a function? And it says, look carefully at the definition. Well, it's not a function, and I'm going to tell you why. The definition states each input has exactly one output. That's what the definition states. A function is a rule that has an input, and your input has exactly one output. But on our graph, when I go back up to my graph and I look at when x is 2, I have two outputs. When x is 2, I have an output of 5, and when x is 2, I have an output of -4. So I'm going to write that down. When x is 2, I have an output of 5, but when x is 2, I also have an output of -4. So same input, two different outputs. Same input has two different outputs. That means that it's not a function. It's not a function, okay? The same input cannot have two different outputs. If it does, it's not a function. Raise your hand if you need more time. Okay. Thank you, ma'am. All right. So example number 3 says the equation y equals x squared gives us the function rule where the output y can be calculated for any given value of x. So we have to, it says, oh, guess what? Here's your domain. The domain is just the set -2, -1, 0, 1, and 2. We need to find the set that represents the range. That is the same thing as saying, let x equal -2. Let x equal -1. Let x equal 0. So let's start with that and evaluate. If x is -2, my function y equals x squared, so -2, the quantity squared. What is -2 times -2? Positive 4. So when x is -2, my output is 4. Okay? What about when I let x equal -1? So my output equals my input, -1, the quantity squared. What is -1 times -1? It's positive 1. Okay? What about when I let x equal 0? My output is my input, which is 0, squared. What is 0 times 0? It's 0. We have 2 more numbers in our domain that we have to look at. We have to let x equal positive 1, and we have to let x equal positive 2. So if I let x equal positive 1, I have y equals positive 1, the quantity squared. Do you guys notice that when I substitute in for a variable, I put that quantity in a parenthesis? That is so important. That is so important. What is 1 times 1? 1, okay? And when x is 2, my output, y, equals 2, close my parentheses, squared. What is 2 times 2? Okay. So notice that when I have the input of positive 1 and the input of -1, I get the same output. Do you guys see that? That was this question right here. Can 2 different inputs have the same output? Yes, they can. We just showed it right here. 2 different inputs have the same output, okay? Got it? Okay. We have to create a mapping. We have to create a mapping to show how each input value is mapped to the output. So let's take a look at our outputs. What were the outputs that we had? What were the y values that we were given? Y equals what? 4, 1, 0, 1, and 4. So when we make a mapping, we want our numbers to be in order from smallest to largest. So the smallest output that we have is a 0. The next one is a 1, and then the last one is a 4. So when I took the input -2, when I let x equal -2, what was my output? When x was -2, y was what? 4. So I'm going to take an arrow and draw it from -2 to positive 4. I'm going to make an arrow. Are you with me up front? When x was -1, what was my output? Positive 1. So I'm going to go from -1 to positive 1. When x was 0, what was my output? 0. So I'm going to go from 0 to 0. When x was 1, what was my output? It was positive 1. So I have 2 arrows going to the positive 1 in the range. 2 arrows. Okay? When my input was 2, what was my output? Positive 4. So I also have 2 arrows pointing to the number 4. 2 arrows pointing to the number 4. We have to represent this function as a set of coordinate pairs. That's the same thing as saying ordered pairs. So let's see. Set notation. So we're going to use a bracket, a little squiggly bracket. And then we're going to write 5 ordered pairs because I have 1, 2, 3, 4, 5 arrows. So I'm going to start with my first arrow. When x is negative 2, my output is 4. So that's the ordered pair, negative 2, 4. I can also go up to my math work, right? When x was negative 1, my output was 1. That's my next ordered pair. When x was negative 1, my output was 1. When x was 0, my output was 0. When x was positive 1, my output was positive 1. And when x was positive 2, my output was positive 4. And then I'm going to close my squiggly bracket. So I have 5 ordered pairs in that set. 5 ordered pairs. The last question says, give the set that represents the range of this function. So tell me what range is again. Yeah, range is the y values. That's all it is. So I'm just going to list all the y values. Our y values are 4, 1, 0, 1, and 4. But we have to write it as a set. We have to write it as a set. Okay? So here's how we're going to do that. We're going to say the range. We're going to use I think that's a colon, right? The range is the set. So what are the numbers that represent our range? We just wrote them down. What are the numbers that represent our range?
4, 1, 0, 1, and 4.
Okay, we have to put them in order from smallest to largest.
0, 1, 4.
0, say that again, Kenna. Is the number 1 the same as the number 1? So you don't repeat it, okay? No, I'm glad that someone said that. So it's 0, 1, and 4. You never repeat I don't want to mess you guys up. I want to think about how I want to write this. You never repeat the same number when naming a set. Okay? The number 1 is the number 1. Even if it shows up in the set 4 times, you only need to name it once. The number 4 is the number 4. Even if it shows up in the set 6 times, you only need to name it once. Does that make sense? Yeah? Okay.